Hello, this is Jeff with nybbles.io, and this is our first Q&A video for YouTube. The general idea is this: if you have a question about software development, about electrical engineering, shoot me an email at the email address that you will see on your screen, and I'll go through these questions, I'll curate them, and produce videos trying to answer the questions and go more in depth than a typical Stack Overflow answer, or even a blog post that you might find. Typically, to answer more complex software development questions, you have to kind of synthesize information from a variety of different blog posts, Stack Overflow answers, documentation. It can be, quite an arduous process. So the goal here is to, hopefully provide an in-depth answer to complex questions. They can be simple too, and if we get a bunch of simple questions, we might devote one video to answering, several of them all in one go. Today's question comes from Chicago Dave, and his question is, how do I register and use some kind of keyed factory type interface in Autofac? And there's actually a couple parts to this question. One is a reflection part, how to dynamically find plug-in types that match certain criteria. And then the other part is how you actually provide instances of those types through factory. And so today I am going to provide two examples of how this can be done. One, what I'm going to call the really simple approach, which is still legitimate. It just doesn't use a container. And then I have a solution that uses Autofac. And we can see kind of what the differences are. Now, in this particular case, Chicago Dave is using Autofac. It doesn't really matter, which dependency container you're using. They all have very similar capabilities these days. Now, you may have to spend some time, unfortunately, in the documentation, kind of mapping one concept to another, depending on your what particular dependency injection container you're using. But I think generally the concepts should be very portable. I know certainly, several containers that I've used over the years in .NET have fit, this general pattern. The APIs might be slightly different, but the general idea holds. So I am using JetBrains Writer IDE, which is really a really nice .NET IDE that's cross-platform. So this problem has a couple parts. So let's restate the problem, and then we'll go through the solution to see how this particular approach addresses the problem. So first, the problem that we're trying to solve here is twofold. One, we want to be able to dynamically find types that either implement a given interface or a base class, or have an attribute on them. And we want to do that by scanning for assemblies dynamically in the file system, find those, load them, find the appropriate types. And we want to put those types in some kind of a indexable data structure, like a dictionary, so that we can later look up those types and dynamically generate instances based on information that's passed into a factory. Now, typically, these kinds of things, right, when we're going to create some kind of plugin or adapter or whatever terminology you want to use, typically they're keyed by strings, enums, maybe numbers, integers of some kind. It could go as complex as some form of structure class that's a complex key that you use to look up these things. But typically, again, the most common approaches you'll see are strings and enums in a language like C# for looking up these sorts of things. In our case, we use strings. And then the second part is, like I say, then being able to call into this factory and get an instance of this type and then use it to do some work, okay? So this first solution is what I'll call the vanilla or plain Jane approach to this problem. So let's go through the assemblies in the solution. We'll talk about what they do, and then we'll talk about how the whole thing works. So first, we have a nibbles questions contracts assembly. This is a class library project, nothing fancy, no real special dependencies here. I have an I plugin interface. This is our plugin interface. It does one thing, compute value. You pass in two integers, and it does something to them. We don't know what. It could be an addition, it could be a multiplication, it could be subtraction, it could be something really complicated, right? And then it returns an integer. And then we have a plugin attribute. And this is what we're going to use to decorate the implementation classes so that we can find them later. Personally, I prefer to use attributes to do this sort of thing. One, it allows us to add additional metadata that's kind of orthogonal and out of band to the type itself. In this case, we want to know what the name, the key, the type is that we're going to look this thing up by. And we could put it on the class, but that's a little inconvenient in this scenario. And then additionally, I personally just think it's easier coding-wise to look up by attribute. Finding things that implement a particular interface or particular base class, that code can be a little bit gnarly, and so I just try to avoid it. So that's what our contract assembly looks like, pretty simple. Those are our interfaces. Now let's take a look at the plugins. So we have two plugin assemblies, two class libraries that have plugin implementation classes in them. And I chose to do it in two different libraries just to kind of make the point that it doesn't really matter where these types live. We can scan any directories we want. We can look in a database for these assemblies. We could download these over the internet if we wanted. That'd be kind of probably not super safe, but you could do it, right? Bytes are bytes, and where the assemblies come from is not really relevant. Also, what's in the assemblies is not really relevant. We have our plugin types here, and we're going to look at these in a second. But you could have other implementation in these assemblies that don't have the attributes on them, and it would all just work fine. And so, there's lots of flexibility here. So in the first plugins one, we have one plugin class called addition plugin, implements the iPlugin interface, implements compute value to do an addition, right? So A plus B returns that value. Then we have the plugin attribute here, and we call it add. The type is called add. This is how we're going to look things up, right? Is by this label. And that could be an enum, that could be a numeric value, that could be a complex value that gets turned into a hash code. So there's a variety of things that you could do there. I'm doing it very simply for the purpose of answering this question. But you can make things as complicated as you want, as you need to, right? Probably not as complicated as you want. And then multiplication plugin is in the second plugin assembly. And this assembly, or this implementation rather, of compute value multiplies A and B together and returns the result. And we call this plugin, we identify this by mul. So that's how we look this one up. Okay, so we've talked about what the contracts look like, really simple. We've talked about the two assemblies that have a plugin class in them, concrete class that implement our interface and have our attributes on it. Now we're going to take a look at the non-container factory. And this is where the guts of this particular implementation live. I'm going to close the Solution Explorer just so it's a little bit easier to read this code because it unfortunately is quite horizontal. So our plugin factory has a static concurrent dictionary on it. This is just out of habit. You could probably, for this, you could use a standard dictionary, but I just, out of habit, I use it. And this is what keeps track of our plugin. So we have the string, that's that value, the type value that's in the plugin attribute, and then the type that name refers to, okay? And then we have our private constructor, and that does two things. It scans the file system for assembly. So let's look at that function. First thing we do is we call directory enumerate files, and we use the app domain base directory property because we just want to scan what's in our running directory. Again, this is for simplicity, for example purposes. This could be any path you want. This could come from a config file. This could come from a database. This could come from anywhere, okay? So, and this, you could have multiple paths. You could have multiple paths, multiple patterns that you want to scan. But what we do is we pass in the base executing path, and then we pass in a pattern here. We know that our full name on our assembly is going to be nybbles.questions.plugins and then something, and then .dll. So we scan for those files, and then we iterate over each file, and we call load from on assembly, which takes the path. There's a bunch of different ways that you can load assemblies in .NET. This, in my experience, is the easiest for loading them from the file system. Again, if you are getting a stream of bytes from a database or over the network, there are other overloads in app domain that are actually probably easier to use in those scenarios. But for the file system, this is pretty straightforward. And then again, just because this is an example, I catch any exceptions out of this and we log them in case there's a problem. So then we go back up to our constructor. We call scan loaded assemblies. So now scan loaded assemblies iterates over the results from this function here, find candidate types. So there's going to be a bunch of types, bunch of assemblies that are in memory. A lot of them we don't care about. We really only care about ours. So this find candidate types takes a functor that has a type parameter and returns a bool to indicate whether or not this particular assembly, or this particular type rather, is a valid type. So we pass in a predicate that says, hey, does our name, our full name, which would include the namespace, does that start with nibbles dot? And then if it does, then that's ours. We'll at least look at it. Now you could, again, you could have a convention here, you know, my product dot something dot plugins or dot extensions or whatever, dot star dot DLL. And then, you know, that would help narrow things down. You can come up with any rules you want here, really. And then so for each type, we get the custom attributes of our plugin attribute, right? The type of our plugin attribute. We cast it, and then we get the first, or we return back a null. Because this can return, theoretically, can return more than one. So the interface here is always an enumerable. We want to turn that into just one instance. So if we got one, then we put that type keyed by that type string that came off the attribute into our dictionary. And we just loop until, you know, we do all that for all the types that match our predicate. And so then after the constructor is finished, we have a dictionary, private dictionary internally that has this information in it. And then we have a public interface here. Oh, and then I missed there's a instance property that actually returns back the instance of the static factory in this case. And then we have a public method, get by type name. So you pass in that type name. So this would be add or mul or div or whatever you would want to call it. Happy Monday, Tuesday, Wednesday. You could call it whatever. Doesn't matter. And then we check our dictionary. Hey, can we get this type out by this key? If we can, then we call activator create instance, and we create an instance of it. Now, this is, again, for demonstration purposes, very simple. Let's say that you wanted to, in this simplistic example, let's say you wanted to inject things into it in the constructor. Well, you know, you could write code here to do that. It's going to get more complicated, and there's going to be more reflection code, but you could do it all yourself. Now, we're going to look at the container version of this, and I think you're going to see that the container version handles all that complexity and does extra stuff as well. But, you know, you can do it plain Jane. You know, I wanted to kind of show that you don't have to do this stuff with containers if you don't want to. The containers just make your life a lot easier. So then we have a command line project, console project, that just has the program class, nothing fancy. And then in main, we use our plugin factory, we get the instance, and we call get by type name, passing in add, the add string. And this is going to go find that in the dictionary. It's going to get the type back. It's going to call activator create instance. It's going to create an instance. We're going to get that back. And if we didn't, then that's an error. We do the same thing for the multiply plugin. And then we just call both of them. And we write out, what it is we're adding and what the result is of that. So if we run this, that's our result. Add 342 plus 42 is equal to 348. Multiply 2 times 16 is equal to 32. And that's the solution there. So again, this is, like I say, this is the plain Jane approach. Now what this approach is showing you is a couple things. One, how you would kind of structure a solution like this, how you would pull your interfaces out, use attributes to help identify things that are orthogonal to your implementation and your contract structure. And then, additionally, you would want to, review the reflection code that's in the non-container factory implementation. Because really the reflection code is the same for the most part, whether you're doing it on your own or you're using some other container, because you still have to populate the container. So this exercise, I did this one first, and this one really kind of showed me what what I would call the minimal bound of an implementation would be for this. Now again, someone might ask the additional question, well, how do I inject this? This is just calling the default constructor. How do I do something more complicated? Well, create instance has overrides on it that allow you to pass objects into the constructor. So you can do that, right? But what you would have to do is a lot of the work that a container would do. You would have to use reflection, you would have to look at the types, or you would have to hard code it. You just have to say that the easy approach, right, would be each implementation of a plugin class takes a logger, takes a, some other implementation interface or something. If you had a fixed set of constructor values and you just always had those, that'd be pretty easy, because then you could just create an array here, you could populate the array with the appropriate values, and then pass that into create instance, and away you go. But it is going to be more complicated in this model because you have to do a lot of that work on your own. You're building it from scratch, so to speak. So now let's close that solution and let's open up the factory version. So all right. So this is the factory version of this is a factory implementation using Autofac of this same problem. So let's talk through this one. It's a little bit different. And it does actually do more than the last one, because again, the container makes our life pretty easy. So first, let's take a look at our contracts. So there's more contracts here because I wanted to actually demonstrate a couple levels of injection, because that's part of the challenge, right? Is that you can have these plugin types, but then how do you inject into the plugin type and so on and so forth. So this kind of demonstrates all that. So the first thing we'll look at is iPlugin, which is exactly the same as what was in the other solution. Compute value is the thing that we're doing here. We take in an A and a B, and A, B, do something to them, return the value. We have our plugin attribute. That stays exactly the same. Nothing changed there. And then we have a couple of new interfaces. We have iLog service. Now again, this is not intended to be a complete logging solution. This is just meant for demonstration purposes as it relates to this particular question. But we have a simple method on here, info, that takes a format and takes a variadic array of values, just like the string format does in .NET, and passes that into the console.writeLine in the implementation. Really simple. And then we have iArithmetic service. The arithmetic service is kind of now where we had the console application before. The program class, the main method was doing, kind of all the work. This just kind of hoists that up into another service so that we can kind of demonstrate multiple levels of injection here and how that would work. So we have execute operation on this, and that takes a string and then the two parameters. So then if we go and take a look, our plugins are exactly the same. They haven't changed, with the exception of some, injection stuff. So compute value does the same thing as it did before. It just now calls the logger that gets injected and writes out, that we're going to do the addition. And then we have a constructor on here now that takes the iLog service instance from the container when this type is resolved. And we just assign that to a private field so we can use it. And the same is true of the multiplication plugin. And we just log out that we're about to multiply. And then if we take a look at services, so this is a new assembly. This is just another class library assembly. And there's a couple things on here. One is the implementation of our two new services. And the third is the configuration for the Autofac container itself. And we'll first look at the log service. Very simple. Have a log service class that implements iLog service, and it just passes literally everything through to console writeLine. So very straightforward. And then we have arithmetic service. Again, this is taking that behavior that was in main in the last example, and it's kind of hoisting it up into a service. So then this service can in turn resolve the plugins to kind of demonstrate how that works. So in arithmetic service, we have a logger that we pass in. We have an iComponent context. So this is a Autofacism. Different containers do this in different ways. This is if you wish to pass a reference to the container into one of your components, this is how you would do it. There's actually two different ways, iComponent context and iLifetime scope. iLifetime scope, I believe, inherits from iComponent context, and iLifetime scope implements more structure based on the lifetime of the objects. Like, so if the object's request based, or if you create your own policy for what the lifetime of an object is, then those classes automatically handle that, and they automatically handle disposing and removing those objects from the container when their scope expires. So this is how you inject the container down the stream so that you can then resolve things like what we're going to do here. So our constructor is nothing special. We just assign our private fields with what gets passed in from the injection. And then our execute operation, first, we want to get the operator plugin. We want to get the instance of the plugin that's going to do the work. And we use this concept of resolve named, which when we talk about the service module, you'll see how this works. But this essentially allows you to say, hey, resolve this type that was registered with this name. So this should sound very familiar. This is just Autofac's way of storing this stuff internally with a key, okay? And so this gives you factory type functionality without really having to do anything special. You don't have to build a factory yourself. The container is the factory. So then if we get back the instance, we call compute value, we pass in A and B, and we return the value. Otherwise, we log an error message, return 0. We should not ever have the error message because everything should work. And then if we take a look at the services module, a lot of this code is going to look very familiar. Find candidate types, scan loaded assemblies, and scan file system for assemblies is code that I just copied from the last solution and put it in here, because this code is literally the same, right, between both solutions. It's not any different, right? Autofac does have some reflection capabilities built into it for, finding specific interfaces and things and registering them that way. But it's limited, right? And it's really meant to save you from potentially having to write 500 lines of code or something to register all these different implementations for interfaces. But in this case, where you have a dynamic situation where you're going to go, you're going to scan file system directories, and you're going to, introspect into those assemblies and find types, you're going to get metadata, you need to most likely write that code yourself. Anything beyond the most simplistic, hey, go register anything that's of this type, right? Then, you're going to probably end up having to do something like this. So then the new piece here is the override on the services module. So services module inherits from module, which is an Autofac class, and there's a load method that passes in the container builder. We register the concrete type of log service that is an iLog service, and it's a singleton, right? So then Autofac will actually take care of that completely for us. We don't have to worry about that. So the singleton here is the lifetime of that type. Arithmetic service, iArithmetic service, and we get a single instance there, right? So that's our singleton. Then we call scan file system for assemblies, and we call scan loaded assemblies. The only change here is I passed the builder into scan loaded assemblies because we don't have a dictionary of our own anymore. Instead, we're calling register type, passing the dynamic type we got as we iterated through the types from the assemblies. And then the named option, this is the variant here, right? So we're saying register, instead of doing as, we say register this type, named, this is the interface, and then this is the value, this is our key. And Autofac has a kind of a shortcut mechanism for strings, because that's a very common scenario. The underpinnings of it are the keying mechanism within Autofac, but you can also, there's a keyed variant here that you can use that does the same thing, but it's more flexible. It lets you do things other than strings, right? So it lets you do enums, it lets you do complex types. So, but for this solution, again, just to demonstrate how you would do this, how you would structure this, this is how this works. And so now Autofac becomes our dictionary, becomes our factory automatically. And the beauty of this is you can do this for any kind of, base interface. So you could have an iAudio plugin, an iVideo plugin, an search plugin, right? All these different kinds of plugins, right? You could register all those with their own identifiers. They could have the same identifier because the type, or you could reuse keys, I guess is what I'm saying, because the type is different in each case. So there's a lot of flexibility here that Autofac is giving you. And these are being registered in our container. So everything's in the container now. That means that we can inject anything, to anything basically, because it's in the container. So now the very last piece is the runner, which you'll see is a lot, it's about the same, I guess, not quite as complex, right? So we create our container builder. This is a Autofac convention. We register our module, and we just new up an instance of that module to do that. And then we build our container. And then we use resolve to get the arithmetic service out of the container. And by doing this, right, we inject, down that chain. And so then from there, we can call service execute operation. That uses the container context, I think it was. Sorry, forgot the name. Let's take a look here. Arithmetic service, iComponent context, sorry. So that uses the iComponent context to resolve the named plugin. So that's our factory. And then From there, it does the addition and returns the value out. And we do the multiplication, returns the value out. So if we run this, we're going to get slightly more output than we did last time because the individual plugins are doing a little bit more work because they have that log service passed into them. And the structure of this, again, is a little bit more advanced because the container allows it to be more advanced. It allows us to pass all this extra state around without really having to do any of the plumbing that I was talking about with the first solution. So here you can see, here's a log message. I'm going to add A plus B. Here's the console write line from main. Add 3 plus 9, we get 12. We're going to multiply A times B. That comes from that plugin. And so that plugin is got an instance of the log service, called info on it. It formatted that output. Then the console write line at line 17 here in main, 16 times 16 is 256. So there you go. I hope that these two examples help. I hope that this makes sense, and that you know, from here you can use this as a foundation to build much more complex discovery and plugin systems for your C#.NET projects. Couple things, just closing notes. This Q&A series is YouTube only. I am going to try to ramp up to getting Q&A videos out daily, Monday through Friday, and I've been kind of stretching my video and audio skills here and editing to their breaking point, so bear with me, but I will hopefully ramp up. Also, I have a daily Twitch stream. You can go to twitch.tv/nybbles.io and watch that. I do stream Monday through Friday, 5 a.m. to 10 a.m. Mountain Time. There is a panel on the my Twitch channel page that shows you my schedule and will adjust for your time zone, so you don't have to do that. I archive my Twitch streams on YouTube, so you should be able to see those here in the YouTube channel if you want to watch those as well. The streams are really my programming routine, Monday through Friday. And I'm working on one common project most of the time right now, which is called Ryu. But on Fridays, I typically switch it up and I do something kind of fun or different. So keep your eye open for those. And then also, I am making progress on my video series that will be released simultaneously here on YouTube and on my website, nybbles.io, called Let's Make an Arcade Game in MS-DOS. And that's going to be x86 assembly language. It's a 52-week video series taking you from nothing, I don't know anything about programming or assembly or anything, to a completed arcade game. At the end of the 52nd week, it'll have everything. It's VGA graphics, it has sprites, it has background, it has animation. We're going to have music and sound. It's the whole shebang. We're not skimping on anything. And you know, it's going to be a incremental pace to take you through the whole process, step by step of what it takes to build something like that. And then hopefully at the end of that process, you're going to know quite a bit about the x86 architecture. So that's it. Thanks so much for watching. Stay tuned for the next video. Bye.